Good afternoon, my name is Alex McDonald. I'm in the office of the CTO at NetApp, and I'm also part of the SNIA Technical Council. So I'm here today to talk about Swordfish, which is a management standard. So Swordfish is an extension of the DMTF's Redfish. I don't know if you've heard of Redfish, but Redfish is a management standard for servers. And when DMTF developed Redfish, they put a slot in there for storage, and it simply said storage. That's all it said, storage. I'll show you the box. It says storage. Doesn't explain anything at all, it just simply says storage. And if there's one thing I really get annoyed by, it's people saying, oh, you know, this stuff's really easy. Storage is the easy bit. You know, it's the processing of the data that's important, or it's the transporting it around networks. No, it's not. Us storage guys do a fabulous job. Do you know that if you give us a bit now, we'll give you that same bit back with the right value in 50 years' time? You try doing that with a CPU. So I think this was an opportunity, and we saw it as an opportunity for SNIA to go out there and say, we want to take the Redfish specification and extend it properly to storage to do a proper job. So that's exactly what we've done, and Swordfish was part of it. There is an extension taking place to the network side, but it's not called Barracuda or anything like that. Does anyone remember what the network side's called? Does anyone know? Can't remember. Anyway, it's not important because that's networking, and we're not really... Huh? Goldfish. Bluefish. So this is a work in progress. You can find the information at snia.org/swordfish. Snia.org, by the way, is a good source of information because you'll find all the technical work that we do in the one page, and you can click on the various links, and Swordfish is one of them. So what are the drivers? First of all, people have been asking for improvements in management APIs. We've already got, though, who's familiar with SNIA? Storage Management Interface for Storage, sort of, yeah. So, Systems Management Interface for Storage. SNIA is relatively complex and heavyweight and consists of an API, quite a complex API, and also is based on work that was done in the 1970s and 1980s with the, anyone come across, you like acronyms? I prefer beer, but acronyms will have to do today. CMOM, which was the Common Interface Model specification that they had for describing IT technology. So it was relatively old-fashioned. SNIA has been stabilized, and we're not going to do very much more work on SNIA. It's at version 1.6, and it's going to stay there. The idea behind this is to go towards more modern interfaces like RESTful interfaces, be able to do this from a browser, be able to have simple HTTP-type requests for getting information back, and also for management. And I'll discuss what we mean by management in a minute. So SNIA schema is split off. We did some work on the schema to simplify it. We did some work on the schema as well to try and modernize it, because things have moved on since the first storage arrays came out in the 70s and 80s. And we wanted to cover block, file, and object, and technologies that we haven't even thought of yet in a flexible and open way. So we took Redfish. Redfish was an Intel specification that they gifted to the DMTF, and we've simply extended on that with the DMTF's permission. So it's an extension. So to understand Swordfish, the place to start is with Redfish, but Redfish is simply a very simple implementation. I'll discuss what it looks like in a second. So who's doing both Redfish and Swordfish? You can see who's doing Redfish. Redfish is the server stuff, quite a lot of people. Swordfish only on the right-hand side, so the pure storage plays on the right-hand side, and people in the middle are doing both. So this is being adopted by quite a lot of the companies that you work for. And the important thing for us is we haven't seen any commercial implementations of this yet, and we would really like to. We need somebody to be brave and step forward and test their Swordfish implementation for managing their storage against our reference set of architectures that we've developed that I'll cover shortly. So this is all being done by the SSM twig. One of the unfortunate things inside SNIA is that every technical work group we have has an S in it. Some have more S's than others, some have less S's than others, but most of them have at least one, some have two. This one's got two. This is the SSM, we've also got the SSF, the SSSI, the SSSI, and various others. But this one is the SSM, the Scalable Storage Management Technical Work Group. Free to join. You do not need to be a SNIA member, although, as I say, your companies probably are. And what we're doing right now is validating the spec, looking at proof of concept, documentation, and there's a plug fest that we run, which is, as you would imagine these days, we don't all get together in the same room. We do the plug fest over the intertubes. So it's an internet-based plug fest that we run. So what does it do? Block storage, file system, and additional, like object drive technologies that we talked about earlier. The important thing here is that what we're trying to do is provide people with more than just a management interface. This allows you not only to provision storage, but schedule, depending on which side of the Atlantic you come from. You can either schedule or schedule storage. You can interrogate storage. You can modify the storage. So not only can you ask for capacity, you can give capacity back. Not only can you get statistics about the quality of service that you might want from your storage, you can ask for storage that delivers a particular quality of service. So what we're intending is a fully extensible set of management interfaces that allow you to do things like, for instance, if any of your Kubernetes fans, anyone fancy Kubernetes? Not even from a distance? The skirt on? Hey, we're all guys together here. You can tell me. No? Kubernetes. When I say Kubernetes, am I getting any reaction at all? Okay. All right, yeah, okay. The other thing to do with this, what we're trying to do here as well is give individual vendors the opportunities to write and interface their own tools with classes of storage they might not have been able to manage before. So for instance, NetApp, my company, being able to go out there and provision on a Dell EMC box because it supports Swordfish. So Kubernetes as an application, or DevOps people who want to do that kind of thing, can provision, manage, implement storage interfaces without regard to the storage provider that underlies it. So that's really the focus of this. And block storage and object cover, block file and object cover the major technologies that we currently see. So, where did Redfish start? Well, there's a Redfish result map. You start with there's a root. Think of this as a sort of structured tree. It's all JSON based, by the way. So it's all what a colleague of mine calls humanly readable if you're not a human. Okay? So it's all. And basically what you've got are various types of records here, including sessions, account, schemas. Schemas describes the thing. Account and sessions are to do with actual management of it, and who's coming on, users basically, logins, that kind of thing. And events, because events are important in terms of the life of a thing like a server. It has events, it gets powered on, it boots, it gets powered off, it reboots. And then you've got a collection of managers. And these managers do things like, for instance, have information on, there's a physical view of the box, a chassis view, and then there's a logical view of the box, the systems that live on it. And that set of cascading information allows you to go out there and manage a server. So what we did was provide two ways to add storage to this environment. The first is the hosted service configuration. So there's the original Redfish. And here's what we added, storage systems. So there's a variety of information about storage systems that we've added to that root. So we've added it to the root, which means that these are standalone hosted storage systems. The dotted lines are referring to logical pointers. And you can see here they've got things like volumes, files, replicas, which might be snapshots or copies. So there's a variety of ways of describing the storage. And then the integrated, which is where you've actually got storage in the box. Think things like hyperconverged. You've got a simpler set of structures that provide for hyperconverged. So you can manage hyperconverged exactly the same way, or just even boxes that you built yourself with storage in them. So the technical work group has got mock-ups of different types of systems that you can go and test against. And they're representations of implementations. They're not part of the standard, but they are representations of them. And here's a quick overview. Most of this isn't readable. But the idea here is that what we can do is, via a simple HTTP request, we can get back this human readable, if you're not human, string that's JSON, and interpret it correspondingly. So you can see there we've gone out and asked for a small information on a small external array, and we're getting back information about the systems, the storage systems that are on it, the chassis information, etc. The detail's not shown in this. This is just simply the classes of information on that particular query. You can select the storage services link to see the collection of storage. And then you can get all the way down to the available classes of storage. Now, the idea behind this as well is that we can do things like, for instance, implement a policy. And the policy might be, when I ask for storage of class Zebra, or Zebra, depending on which side of the Atlantic you come from, then you would get certain characteristics. In other words, I want this data replicated or striped. Do you like that? Is that any Zebra? Oh, never mind. So you set characteristics you want for this particular piece of storage. It might be striped, it might be very fast, have low latency, high bandwidth, might be local, might be remote, might be in the cloud. You set these characteristics, and then I can go out there and manage a thing called Zebra. I can go and ask it for Zebra storage. You know, give me a lump of Zebra storage, wherever the lump I've defined for Zebra might be. Might be gigabytes, might be terabytes, might be object. So if we had Rhino data, you could go out there and ask for, you know, Rhino data might be stuff that's backed up to tape every 10 minutes. So the whole point of this, though, is to be able to describe your storage in ways that suits you, and then be able to manage them in those particular object categories. Still being able, though, to manage the logical services that sit on top of the device, and also the physical devices themselves. Okay? So there's an example of a file one, and I say they're not particularly readable. I had a better set of slides than this, but they've been ignored. So, and you can do things like, for instance, here's a query: do I have space to? Is there enough space on this particular kind of request for you to be able to satisfy it now? And you can check on the remaining capacity. So here's what you can do. For instance, you can do basic Swordfish support. Basic Swordfish support is a very one-way thing. Tell me what you know. It's very it's unmanaged almost. And then you can add on functionality, and you can do. I mean, the other thing is that what we're planning to do as well. Here's an example where we're going to extend Swordfish in a standards-based way to do Energy Star requirements, because that's becoming increasingly important. It's funny, actually, Energy Star is becoming increasingly important because energy is becoming really important, but SSDs and flash technologies are decreasing our power consumption per bit. So there's a number of places I know where they're actually just racking up flash because they can support the flash and the infrastructure they've got. They don't need to think about putting more power into the building. That's always been an issue with spinning disks. And then getting rid of the heat. So 1.0.6 was released 2018 February. We've got future functionality coming along. One of the things that we're looking at is security roles. There are Redfish security roles, but we don't have any storage-specific security roles yet. That's actually an important point, because as we know through things like Spectre and Meltdown and the recent Intel problems, sharing stuff is always a problem. There's always a bad guy out there. Spares management, rebuild management, so there are a whole bunch of areas we could extend this to, but we need people just to adopt it first of all. Object storage we haven't actually addressed yet. They're still defining the object storage interfaces and the KVM pieces, so once they've done that, we'll do this as well. So there's an online practical guide, there's a Swordfish school, and there's an API specification. The specification, by the way, is ridiculously trivial, as you would imagine, simply because it's RESTful HTTPS. The queries are relatively straightforward. About the only thing you need in front of you when you're doing Redfish or Swordfish type work is the JSON hierarchy. Moving through the hierarchy is relatively straightforward, but knowing how the hierarchy is structured is the important thing. And there are lots of webcasts about Swordfish. There's also an open source piece. We've done an emulator and a Webfish client. The client is actually just a very simple HTTP get and present interface. And we're hoping to have a lot more to show shortly, but it does take development effort. What we really want to see is member companies and non-member companies adopting this Swordfish interface. That's what we really want to see. Because as soon as we start seeing that, it makes building work on it much easier, because we'll then have people with experience of using it and providing it. We'd like to see a large cloud provider do this. Will it happen? Don't know. But we would like to see it. Thank you.